Dear student, let us start a very important chapter of calculus. Is one of the main branch of mathematics. We have already seen differentiation. Let us start integration. Integration have two different branches. One of them is indefinite integration, and second branch is definite integration. Clear? Even let us start indefinite integration. Before defining indefinite integration, I would like to define antiderivative. Or primitive or inverse differentiation or derivative. Clear? Now for any function f of x on any interval I, if there exists function capital F of x such that d by dx of capital F of x is equal to small f of x, means given function, then capital F of x is called antiderivative. Of f of x. See, this is the definition. Now one note, antiderivative of a given function is not a single function, is a family of functions. For example, let us consider y is equal to sin x plus 1 and y is equal to sin x plus c, where c is arbitrary constant, or just we can say that is a constant. Now see, what is the difference between this one and this one? Here one is a fixed constant, here c is an arbitrary constant. So let us differentiate both functions with respect to x. dy by dx is derivative of sin x is cos x and derivative of 1 is say 0. Same way here derivative of constant term is 0 and derivative of sin x is cos x. Now see, we have a derivative of a function cos x of this function as well as this function. But see, this one is a family of function because that depends on various value of c, we get various functions. So antiderivative is a family of a functions. Hence, whenever we are going to define indefinite integration, we are going to use this concept of constant k. Let us see, let us define it. See, for function f of x on any interval I, if d by dx of f of x plus c, capital F of x plus c is equal to small f of x, then integration of f of x dx is equal to capital F of x plus c. This is the definition of indefinite integral. Here we are going to say that c is a constant of integration. Clear? Now see, keep this thing in mind. D by dx of capital F of x plus c is equal to small f of x, then this integral f of x dx is equal to this much. Now let us see one note. Usually integral is denoted by I, f of x dx. Clear? Now see, f of x is called integrand, and whole this portion of value of this one is known as integral. The process of finding integral of integrand function is called integration. Clear? This is the definition of integration. Now please see here, the process of finding integral of integrand function is called integration. Now let us see some working rules of integration. Few of them today we are going to see. Working rules. Clear? Among first one, integral of f of x plus g of x dx, you can take number of addition of number of functions, but for example here we are taking only two functions, that is equal to integral f of x dx plus integral of g of x dx. Clear? Here if you want to prove it, see here, as per the definition, see we have to see the differentiation of right hand side should be this function f of x plus, then we can write this one. This is the definition. And now see, we already seen that integral f of x dx is equal to capital F of x plus c. If you differentiate with respect to x on both sides, then what we get? See here, this integral f of x dx is equal to d by dx of f of x plus c, and that is our given function f of x. That means whenever integral part is given to us, and if we differentiate it with respect to x, then we get original function. Clear? Keep this thing in mind. So let us differentiate right hand side. D by dx of integral f of x dx plus integral g of x dx. And that is equal to, as per working rule of differentiation, we can differentiate term by term whenever addition or subtraction is given to us. Integral f of x dx plus d by dx of integral g of x dx. Now we know that that is equal to f of x, and we know that that is equal to g of x. So derivative of this portion is not this one, and therefore this integral is equal to this much. Now please see here, second working rule. On same line we can prove it, but right now we are not going to prove it. That is equal to, whenever difference is given, so we can write in this way, integral fx dx minus integral gx dx. Also third working rule, that is constant k into f of x dx. Whenever constant is given to us, keep one thing in mind. Whenever calculus is concerned, that means either limit or derivative or definite integral or indefinite integral, we can take constant quantity k outside. That is equal to integral f of dx, where k belongs to R. Right now we are using only these three working rules. Of course, there is a product rule also. That thing we are going to see later on, and name of that rule is integration by parts. But see, in case of limit, in case of differentiation, in case of limit or derivative, we have a division rule. Clear? But as far as integration is concerned, integral f of x or g of x dx cannot be equal to integral f of x dx or integral g of x dx. This is the limitation of indefinite integration. So there is no division rule. Keep this thing in mind. Now let us see some standard forms. Standard forms or important formulas. Important formulae. First one, all of you are familiar with this form. X raised to n x dx is equal to x raised to n plus 1 over n plus 1 plus c, where n is different from minus 1. You already seen 11 science as far as physics is concerned, to so many times use these standard forms in that subject physics. But here we are going to see in general form. Now let us see. This one is, of course, if you differentiate this right hand side, then you get this function x raised to n. So there is no need to prove it. Now let us see general form. Some linear form is given to us, ax plus b raised to nx dx, and that is equal to 1 by ax plus b raised to n plus 1 over n plus 1 plus c, where a is not equal to 0 because it is a linear form. Whenever linear form is given to us, leading coefficient a should be not equal to 0. If we differentiate this portion, then we get the original function. Let us try it. See, d by dx of 1 by ax plus b raised to n plus 1 over n plus 1 plus c. If we differentiate it, what we get? See, 1 by is constant quantity, so we can take outside. 1 over n plus 1 is also constant, so take it outside. D by dx of ax plus b raised to n plus 1, and derivative of constant term is 0. So that is equal to 1 by a, 1 by n plus 1. What is derivative of some function? N plus 1 into ax plus b raised to n plus 1 minus 1 into d by dx of this linear form, and that comes out a, and this one is ax plus b raised to n, n plus 1 cancel into 1 by a, 1 by a, 1 by cancel. What we get? Ax plus b raised to n. So proof of this one is that. Now let us see one more standard form, that is the second one. integral of exponential function e raised to x is same as e raised to x plus c, general form. E raised to ax plus b dx, linear form is given to us, power is linear form. So that is equal to 1 by a e raised to ax plus b plus c. Very easy to prove it. Right now we are not going to prove it. Now third one is integral of a raised to x dx is equal to a raised to x over log a base e plus c, where a belongs to r plus minus 1, that is a positive real number other than 1, that we know. And keep one thing in mind, whenever base of logarithmic function is not mentioned, then we have to understood that is e. That means in place of this one we can write log a also. Clear? Let us see a raised to x over log a base e. Now it is easy to prove it. Right now we are not proving. Now general form. A raised to some linear form. Let us consider Lx plus m into dx. That is equal to 1 by L a raised to Lx plus m over log a base e plus c. Clear? Is this one. Now next one is in terms of logarithmic form, fourth one, 1 by x dx is equal to log magnitude of x plus c. See, now let us see here. See, if x greater than 0, then this implies mod x is equal to x. So log mod x is equal to only log x base e. And so if we differentiate it, d by dx of this one is equal to d by dx of this form, and that comes out 1 by x. Is it clear? Same way, whenever x is less than 0, then mod x is equal to minus x, and therefore logarithmic of magnitude of x is equal to log of minus x. If we differentiate with respect to x with this function, that is equal to d by dx of this function, log of some function 1 over some function into d by dx of that function, that is minus x. That what is derivative of minus x? Minus 1 over minus x, and that comes out 1 by x. Is it clear? So this proof of this result we can prove in this way. Now see here. Here base is e, and x is not equal to 0. Now what can you say about linear form? 1 over ax plus b dx is equal to 1 by a log mod ax plus b plus c. Clear? See, we have to understood that a is not equal to 0 whenever we are using linear form. Clear? Now let us see some problem based on this one. See, for example, first one, I is equal to, let us consider x raised to 5 by 2 minus 2x raised to minus 1 by 2 plus 3x raised to 3 by 2 plus e raised to x whole into dx. Let us integrate this one. Now see, as per the working rule, we can separate it one by one term. See, this one is the exponential function, this one is the rational form, this one is also rational form, this one is also rational form. So that is equal to, separate term by term, integral x raised to 5 by 2 dx. 2 is constant, so take it outside. 2 x raised to minus half dx plus 3 integral x raised to 3 by 2 dx plus integral e raised to x dx. Use the standard forms. Here each one is of this one, and this one of the form x raised to n. So use that form. So x raised to n plus 1, 5 by 2 plus 1. 5 by 2 plus 1 comes out 7 by 2. Clear? So use here. So x raised to 7 by 2 over 7 by 2 minus 2, x raised to minus half plus 1, that is half over 1 half plus 3, x raised to 3 by 2 plus 1, that comes out 5 by 2 over 5 by 2 plus e raised to x, because integration of e raised to x is there, plus constant of integration c. 2 by 7 x raised to 7 by 2 minus 4. Can I write root x? Yes. Plus 3 into 2 means 6. 6 by 5 x raised to 5 by 2 plus e raised to x plus c. Very simple example. Clear? Now let us see second example, that is integral of 7 raised to 3x minus 2 dx. Exponential form is that. So that is equal to, can I write, let us mention that form, integral a raised to lx plus m dx is equal to 1 by a raised to lx plus m over log a by z plus c. Not here a, but here l. Clear? So what we get here? That is equal to 1 by l a raised to lx plus m over log a by z plus c. Clear? Very easy form. Now third example, let us consider I is equal to 1 over 3x plus 2 dx. Linear form is there, and that we know. Let us give the mention the reason. 1 over, whenever ax plus b is given to us, then what is the standard form? So that comes out 1 by a log mod ax plus b plus c. Use that form here. That is equal to 1 by 3 log mod 3x plus 2 plus c. Is it clear? Now this is just practice of that standard forms. Now let us take one more example that consists all these forms. Let us see. I is equal to root x minus cube root of x raised to 4 plus 7 over cube root of x square minus 6 e raised to x plus 1 whole into dx. Now see here, how to integrate this one? See, as per the working rule of integration, we can separate term by term. See, this can be written as x raised to 1 by 2 dx minus integral x raised to, can I write 4 by 3? Yes. Dx plus 7 common, take it in numerator. Can I write x is raised to minus 2 by 3 dx? Yes. Minus 6 integral, e raised to x dx plus integral 1 dx. Now see, as far as integral of 1 dx is concerned, please see here. Integral of 1 dx is equal to, can I write x raised to 0 into dx? Yes. So use that form, x raised to 0 plus 1 over 0 plus 1, and that comes out x. So integral of 1x dx is, it comes out x. Now see, this one, and last one are of the form x raised to n, and this one is the exponential form. Very easy to calculate it. Now you can write directly also x raised to 3 by 2 over 3 by 2, that means into 2 by 3, minus x raised to 4 by 3 plus 1, that is x raised to 7 by 2 into 2 by 7 plus 7 x raised to minus 2 by 3 plus 1. What comes out? Minus 2 plus 3 by 3. That comes out x raised to 1 by 3 over 1 by 3. That is 3 into this one. Plus 3 into x raised to 1 by 3 into 7. And that comes out 21. Clear? Minus 6 e raised to x plus c. Directly you can write in this way. Clear? Very easy to see that thing. Now, let us consider one more example. I is equal to integral 1 plus x cube upon root x dx. How to integrate it? See, in denominator quantity, single root x is given to us here, and here cubic polynomial is given to us. So we need to expand it. What is formula of a plus b cube? That is a cube plus 3a square b plus 3ab square plus b cube. Use this one. That is equal to a cube plus 3a square b plus 3ab square plus b cube, over root x whole into dx. Now, using the standard forms, now separate one by one term. What you get? See, here single term is there. So we can separate one by one. So that comes out x raised to minus half dx plus 3 x over root x, that is x raised to 1 by 2 dx plus 3 integral x square minus 1 by 2 x raised to 2 minus 1 by 2, that comes out 3 by 2 dx plus x raised to 3 minus 1 by 2, 3 minus 1 by 2, that comes out x raised to 5 by 2 dx. Now, very easy to integrate it. Use x raised to n form, standard form, then you can solve this one. So, let us see next form. Next one, please see here, I is equal to x cube plus 4x square minus 3x minus 2 upon x plus 2 dx. Dear friends, now see here. Numerator is cubic polynomial. See, this numerator is cubic polynomial. Denominator quantity is linear polynomial. Keep one thing in mind. Whenever I is equal to polynomial px over polynomial qx is given, either of any degree, whenever degree of numerator polynomial is greater than or equal to degree of denominator quantity or denominator polynomial, then either denominator quantity or factor of denominator quantity can be arranged in numerator. Clear? See, keep this very important thing in mind. Whenever you are integrating polynomial form, whenever numerator is polynomial, denominator quantity is polynomial, and whenever degree of numerator is greater than or equal to degree of denominator quantity, then either denominator quantity or factor of denominator quantity can be arranged in a numerator. So use this standard form here. How to arrange it? See here, cubic polynomial, so put 3 times x plus 2. X plus 2, because power 3 is there, over x plus 2 into dx. See, of course, this one is the factor form. Now see, here first term is x cube, so we need to multiply it by x square. X square into x comes out x cube, plus what we get? 2x square, x square into 2 comes out 2x square. Here we want 4x square. So we need one more 2x square. Here x is there, so plus 2x into x comes out 2x square. So we get the second term. Plus extra term we get here 4x. 2x into 2, that comes out 4x. But here we want minus 3x. So here we need to take minus 5. 4x minus 3x, sorry. So only minus sign is there. 4x minus x. Then it comes out plus x. But what we want? We want minus 3x. So here what you get? Minus 7x. If I write here minus 7x, 4x minus 7x, then we get minus 3x. So here write minus 7. Minus 7x, this one. Now see here, that extra term here we get minus 14. What you get here? Minus 14. But what you want? We want minus 2. So can I write plus 12? So minus 14 plus 12 comes out minus 2. Clear? So in this way, let us see this one into dx. Now take x plus 2 common throughout. X plus 2. So what you get? X square plus 2x minus 7. Here you get 12. Clear? Plus 12 over x plus 2. Now we can separate it term by term. So x plus 2 get cancelled. What you get? X square plus 2x minus 7 plus 12 over x plus 2. Now it is easy to integrate. That means whenever polynomial is given of this form, numerator is polynomial, denominator quantity is polynomial, then we have to follow this pattern. Now here we can write x square plus 2x minus 7 into dx. There is no need to separate it also. If you separate, then there is no problem. 1 over x plus 2 dx. And that comes out x cubed by 3 plus 2 into x square by 2. 2 cancel. So x square minus 7x plus 12. What is a? Ax plus b. A coefficient of x is 1 here. So coefficient of x is 1 here. So what comes out here? 12 by 1 log mod x plus 2 plus c. Clear? Whenever denominator quantity 1, there is no need to write that thing. So we can write simply 12 is also there. So this is the standard forms. Now see, how to see one more thing. Now I would like to mention some problem for homework. See, exercise 7.1 of NCERT. Let us leave for you. Very simple, based on these forms. Now, among this one more thing. First one, let us leave this sum for you. 1 minus x, 2 plus 3x, 5 minus 4x into dx. Multiply this term, and this term, and get it the standard forms. Second one, I is equal to x raised to e plus e raised to x plus e raised to e. Let us solve this one. Now see, x raised to e is not exponential form, but is of the form x raised to n. E raised to x. Clear? Now e raised to is constant term, so take it outside. 1 into dx. So what can you say about this one? X raised to e plus 1 over e plus 1 plus e raised to x plus e raised to e into x plus c. In this way we can solve it. Now next one, simple thing. If antiderivative is given to us, if f dash x is equal to 3x square minus 2 by x cube is given, and f of 1 is equal to 4 is given, then find fx. Then find f of x. Now see here, f dash x is given to us. Here f dash x is equal to 3x square minus 2x cube is given to us. So what is f of x? F of x is equal to integral of f dash x dx. Clear? So that is equal to 3x square minus 2 by x cube into dx, and that is equal to 3 integral x square dx minus 2 integral x raised to minus 3 dx. So this comes out 3 into x cube by 3 minus 2 into x raised to minus 2 over minus 2 plus c. So what you get? X square minus plus 1 by x square plus c. This is f of x. But see, here one more initial condition is given to us. So use this condition. Now for x is equal to 1, f of x, or just use that, f of 1 is equal to 4. Therefore, 1 square plus 1 by 1 square plus c is equal to 4. So 2 plus c is equal to 4, and therefore c is equal to 2. So what is f of x? F of x is equal to, use this form, x square plus 1 by x square plus 2. This one is the required function. On same line, you can obtain one more sums also. Let us leave for you. Second sum, if f dash x is equal to 8x cube minus 2x and f of 2 is equal to 8, then find f of x. On similar line you can solve this one. And see, one more thing, if f dash x is equal to 4x cube minus 3 upon x raised to 4 and f of 0 is equal to 3, f of 2, sorry, f of 2 is equal to 0, then find f of x. So I am leaving these 3 sums for you. I would like to also mention some OR forms. I is equal to integral root x minus 1 upon root x whole square into dx. Fifth one, I is equal to x square minus 1 by x square raised to 5 into dx. How to expand this one? Some function raised to 5 can be written as some function cube, some function square. Use this form here, then you can solve it. Sixth one, x square 2x plus 1, I is equal to 2x plus 1 whole cube upon root x into dx, x greater than 0. Try to solve this one. See, dear friends, up to this thing, this one is just a revision, means just a practice of that 4 standard forms. Using that 4 standard forms, we can solve this thing. Later on, we are going to see in next lecture.